We're live.
Well, welcome to the demonstration stage here at the Maryland Science Center. This is the recipe for sugar. Actually, there are different kinds of sugar. The particular recipe here is for sucrose. You might call it table sugar or granulated sugar. It's a pretty simple recipe. Sugar is only made out of three elements. The C for carbon, H for hydrogen, and the O for oxygen. Carbon, hydrogen, oxygen. That means that sugar is a carbohydrate. And if you take a look at the recipe for sugar, there's an important piece of comparison here, an important ratio. It has to do with the fact that there are 22 hydrogen atoms and 11 oxygen atoms in a molecule of sugar. Now, if you think about it, this is twice as much hydrogen as there is oxygen. H 2 times O, H2O. And that means that, according to the elements that are here, it looks like sugar has a lot of water in it. And in fact, our reaction today is going to be about removing all of the water, H2O, out of sugar. And that leaves us with only one element left, carbon. So watch for that to be the product of our reaction. But there'll be another product as well. It'll be this water. Now, water is going to appear as steam because the reaction is a very hot exothermic reaction. It releases a lot of energy. When you break the chemical bonds between these elements in the molecule of sugar, it releases a lot of energy. So here's what we've got. We've got sugar, table sugar, sucrose, in different forms. This is what you probably put on your cereal in the morning. This is granulated sugar. This is confectioner sugar, also known as powdered sugar. It's the same stuff, only much more finely ground up. It's a powder after all. And these are sugar cubes. I don't know if you've ever seen sugar cubes before, but all they are is sugar that's been compressed into big chunks like this. Makes it easy to drop into beverages if you're looking to sweeten up your coffee or tea. So what I'm going to do is use this chemical, which sure looks like water, but it sure isn't. This is sulfuric acid. Sulfuric acid is also known as battery acid. And this particular sulfuric acid is concentrated sulfuric acid. And this stuff loves water. It loves water so much that it will rip it from any place it can get it, including ripping it right off of a molecule of sugar. It'll also rip it right off your skin. And so we've got to be very careful in handling concentrated sulfuric acid. So I'm going to add concentrated sulfuric acid to sugar cubes and see what happens when we start removing water from sugar. I'm going to mix it in. Make sure all the sugar gets covered. Let's add some to granulated sugar. Mix that in. Some to powdered sugar. And mix that in.
Ooh.
You can see all this steam that's coming off here. That steam is in fact the water that's being ripped out of the sugar molecules. And what's climbing up out of the beaker is what remains, which is that black elemental carbon. So all this water is what the acid has removed from the sugar. Let's think about something else that just took place here. We had powdered sugar, we had granulated sugar, and we had these sugar cubes. They're all made of sugar, but the reaction happened at different rates. The fastest one was the powdered sugar, then the granulated sugar, and this sugar cubes are, yeah, they're turning black, but they're not reacting in the same rate. They might do it over time. It's going to take a lot longer. So when chemists want to change the rate of a reaction, they have different ways to do it. One way is to change the temperature of the reaction. Another is to change the pressure that the reaction takes place under. And another way is to change how finely divided, how finely ground the reactants are. So now we're getting some reaction out of our sugar cubes. It takes a while for them to soak up all that acid. But that's because they're chunks of sugar. This is granulated sugar, finer grind, and this is powdered sugar, super fine grind. Now, if you were here, you could get a sense of some other chemicals that are produced in this reaction. A small amount of sulfur oxide and carbon dioxide, which has no smell, but works out in the chemistry of the reaction. So, I know it looks like the sugar is all burned up, but this is not a combustion reaction. Combustion takes place when you take fuel and you combine it with oxygen. That's not what happened here. What we did was use one chemical and remove the water. When we rip off the water, that's called dehydration. This is not combustion, it's a dehydration reaction, and what we're left with is the carbon. Glad you could join us here at the Science Center's demonstration stage. Come back and see us when we have other demonstrations for you.